So let's create a function to solve the maze. Let's call it solve the maze. It will take the maze matrix. It will take the x position of the red, y position of the red, the solution matrix, and n. N is the length of each row, or you can say each column. Now the first thing we're gonna do is to check if the current cell is inclusive or not. That is, can we take the current cell in solution? If yes, we will add 1 for that cell in the solution matrix. So xy, we will update the cell as 1, that is, we are including it in the solution. And when it is inclusive or safe to take that cell, let's create this function isSafe, and let's pass the input parameters. Let's pass the maze matrix, x coordinate, y, and n. So we can take the cell when x and y coordinates are inside the maze, that is, x is greater than or equal to 0, and it is less than n, that is, it is inside the maze. And same is true for y coordinate. So y is greater than equal to 0, and y is less than n, and the cell must be having value 1. That is, it must be a valid path, or the cell must not be an obstacle. So if this is true, then we will return true from here. So now after selecting the cell in the path, we're gonna move forward from here. First, we're gonna go in x direction. So we have taken x as rows in this example. So when we change x, then we are changing the rows, right? So actually we are moving downwards when x change. So let's go downwards. Let's solve the maze recursively, and let's pass the maze, and as we are going row by row, we will increment x and we'll keep y same, and we'll pass the other parameters. And here we will return true if from here we can find out a path. Now we will go in forward direction. So y is forward direction, y is for columns. If we change the column, that means we move horizontally, right? So let's solve the maze recursively. And let's pass the parameters. We will increment the y this time, and the solution matrix and n, and if there is a path in this direction, we will return true from here. Else the current cell cannot lead us to a solution path. So we need to backtrack and undo our decision for the current cell. So we will set the cell back to 0. So solve xy and make it 0 again. And from here we will return false. So this is the solution, and now the base case is when we reach to the last cell, right? That means we have found out the path. So last cell is when x is n-1 and y is n-1, and the value of that cell must be 1. So if this is true, then here we will update the value for this cell in the solution matrix. So this is 1, and we will return true from here. This is it. This is the solution. Now let's take maze matrix. Let's create a maze matrix. Let's say const maze, and this is a 2D array, right? So let's pass the values here. Let's say 1 1 0 0. Now let's copy this and let's form other rows, and the second row is having values 1 1 0 1, and now the third row is having value, let's say 0 1 0 0, and now the fourth and the last row that we're gonna take for this example is having 0 1 1 1. Now let's take another matrix, solution matrix, in which we're gonna put the result, the final path. So let's initialize each cell of the solution matrix with 0. For rows, I should be less than n, and here let's fill each row. So here we're gonna create new array of size n, and we will fill all the cells with 0. So we have created the maze matrix and solution matrix. Now let's solve the maze, and let's pass all the parameters. Pass the maze matrix, pass the initial x coordinate. So initially x and y will be 0 0. Now the solution matrix and n, which is the length of this maze matrix. So now if this is true, that means we have found out a path in this maze, and then we can print that path, or we can print the solution matrix. So let's print the solution matrix in case solve the maze returns true. Less than n and increment I, and now for column let j 0 till less than n j plus plus, and here let's take a string for string and string for each row, and here let's concatenate the values for the current row, and let's print the values console.log and print the string. So else we gotta print no path available, as there is no path that can be traversed by the red to come out of that maze. So no path available. So now this implementation is ready. Let's run this on terminal. So here let's run it. Let's say node, first we have to go to backtracking, and here let's say node red in maze. Oh, we're getting error. Oh, we haven't taken the length of maze matrix in n, so let's say n is maze.length. So now let's try rerunning it. So here we go. This is the path that the red can traverse to get out of this maze. Here we are taking X direction first, so it is picking this path which is first going downwards. If we take Y direction first, then it will take the other path, the other available path. So if we rerun this and this time see the path, it takes this one. So this is how we can solve this rat in maze problem using backtracking.